Greetings, programmers. Busted Thumbs back again with Fluffy Wishes.
Hello!
And we're back for our 9th installment of creating our Frogger competition. And if you recall from our last installment, we had a pretty good game going, didn't we? We had our cars. If I make this bigger, I'll go ahead and play it. And they were coming across the screen. Now, Fluffy Wishes and I were playing this game a little bit while you were out, and the frog can go up and down, left and right still too. And the one thing that we changed in between these sessions is that we made the cars go at a little bit of a different speed than we did than they were going when we stopped last time. And if you recall, we did that inside of the stage. If you went to the scripts inside of the stage, all of that information was right here in our initialized lists. The speed of the cars is set to how many pixels over they're going to move with every tick. And we had some funny numbers in there like half and 1 and 2. And 2 was definitely too fast and half was definitely too slow. So these are the numbers we came up with. Which car is this one?
That is the truck.
Nope.
Nope.
Nope, this one's the truck.
Oh, then that one's the red car.
Yeah, this one's the red car. And this one is blue car, I think?
Yep.
No, orange, and then the truck. That's the order in which they go in the list. So we made the red car go a little faster, and pretty much all the others slowed down a little bit. The other thing which we realized was that we had just kind of typed some random numbers into the car delay, and the car delay is the number of ticks that are going to happen when. What is the car delay? What happened?
The car delay is the number of ticks in between each car in the row.
In a particular lane.
In a particular
So
lane.
if this one is still the bottom car, the red one, what does it mean?
That means that there will be 8 seconds in between each red car.
Yep, that's right. There's 8 seconds because there's 30 ticks in a second. So after the first car goes by, there should be 8 seconds. Now we haven't done that yet. That's what we need to do next. And if you'll recall, it's the frog that actually keeps track of when a car comes into view. So if we come down here to check for new cars, what we were doing before is we were looking at the last car tick. That's when that car last came on. And if it was less than 0, which is the condition that happens at the start of the program, then a car came on. That's why there's always a car for every one of the lanes. What we need to do is we need to add to that. And we need to make it so that this condition here happens in more than one case, which means we need an OR. Because if the left hand is true on an OR, it's true. And if the right hand is true on an OR, it's
false. Or it's also true.
It's also true. An AND would make it so that both need to be true.
Yeah.
But an OR means that only one needs to be true. So good. So we need another condition. And in this case, what we would normally think is, my first approach would probably be to go like this. And what I would do is I'd take that mod operator. And I would take the number of ticks that we are working with, and I would mod it by the item of index into our car delay and say that that should equal to 0. What does that mean? The car delay, as we said in that first one, is 8 seconds, right? Or is the number of ticks that represent 8 seconds. And what this mods is doing, because this is our second time we've used this here, right? It's saying when that tick becomes exactly 8 seconds, or twice 8 seconds, 16 seconds, or 3 times 8 seconds, in any one of those cases, if that happens because it's equal to 0, the remainder has become 0, then we're going to create another car. There's a problem with this though. And the problem with it is that if you look up here where we do our game loop, we're calculating what the tick is, the next tick's going to be. And it's going to represent 1/30th of a second since the start of the game. Our desire is that our game has a tick every 30th of a second, but if there's too much going on, it might be 2/30ths of a second or 3/30ths of a second. And when that happens, our tick won't exactly, not every tick will show up, right? So if it's happening every 3 ticks, every tenth of a second, so 3 ticks are going by, we only have a 1/3 chance of hitting this particular scenario. And I think maybe you'll even see it if we were to run this now. You'll see some of the cars come in and others wouldn't. So we'll let a little bit of time go by. And hopefully, there you go, we've got a second orange car, which is good, it showed up. But I think we're actually missing some of the other cars that should have showed up, and trucks and the like. Yeah, so all 4 of the lanes should have showed up with new cars by now, but only the orange did. And the reason for that is pretty simple. It's that our ticks are not hitting on exactly the right cadence, the right frequency that we need them to. So the best way to fix that, remember that we didn't just keep track of ticks, we also kept track of frames, and we haven't used frames yet. But frames is the number of ticks that has happened since the last tick. It's simple. We've done it right here, the subtraction. It's the tick minus the last tick. So if we change this to not be an equals operator anymore, and we go instead with this guy, and we pop frames in there, and I think we're at a better place, because this should now keep track of not just if we exactly hit it, but if we hit it or exceeded it by that amount that we needed that has gone by. So let's see how that works. So they're going to go across, and we should start seeing at least 1 additional car in each of the lanes. There's another orange one, there's another blue one, there's another red one, there's another truck. Can we get through it all? Yes, we can. And there's a third blue car, so that's good. Alright, we do have a problem though. You see this happening on the side of the screen? We're not getting rid of our cars as they get off to the edge, and actually that's just going to make Scratch worse and worse as time goes on, because each one of those is a sprite. Each one of those takes up some resources to figure out where they should be. So now that we've got new cars coming onto the screen, I think what we need to do is get rid of the ones that we don't want. And we can do that inside the cars themselves. Now here, when we're positioning the cars on this screen, we're setting their Y, and that Y really shouldn't be changing much, and we're also setting their X. I'm a little concerned about setting their X. And the reason I'm concerned about setting their X is, you see these guys bunching up on the side here? We told it to keep going to the right. But after a while, Scratch says, I don't want to draw a sprite that's off the screen too far. And so it's keeping the X from going further than we want it to. So what I would like to do is actually create a new variable for this sprite only. And I'm going to call that my desired X. That's the place I think it should be. And I don't need for that to show. So what I'd like to do here, instead of setting X to these things, I'd like to go ahead and set the desired X to the things that we've calculated. Like this. And then only after that's done will I set the X to the desired X. Now why did I do that? The reason I did that is because I want to use the values that our math computed to figure out if they're off the screen. And if I just set the X to that thing and then I ask Scratch what the X is, I think it's going to tell me the lie. It's going to tell me the one it made it be, not the one we told it to be. So there we are. We've got where we think it ought to be, the X position, and we got where we the actual X position being set. And I think what we want to do now is check if off screen. So this guy's going to go ahead and check to see if he's off the screen. Now there's 2 things we have to consider here. One is if it's traveling to the right, and one is if it's traveling to the left. So we have 2 conditions to worry about. I'm going to go ahead and drag this guy down to the bottom and work on this guy now. If then else. We kept track of the position, the direction, right? in it right here.
Yes.
And what did we set direction to? There were two values.
Right and left.
And left, all right. So if it's traveling to the right, traveling to the right is actually the harder case. Well, it's not that hard. Let's go ahead and do it anyways. If it's traveling to the right, then if its X position gets bigger than something, we're going to want to delete it. Delete this clone. If it's traveling to the left, then if its X position gets smaller than something, that's when we want to delete it. And it's not the X position, but actually the one we calculated, which is the desired X position. Okay, so now the only complicated thing here is to figure out what that should be. The left and to the right. So left to the right, it's when it gets, remember the X position goes all the way up to 240. So really it's 240 plus half the width of that car, right? So we're going to have to add, and we're going to have to divide. 240 plus something in half. And the width of the car is we keep track of here. Car width, right? So car width is a list, and the way we look things up in a list is the item of, and it's going to be its lane number. Right. The lane number is, although again we count from
0
and Scratch counts from
1.
So it's not just the lane number, it's the lane number plus 1. So data, lane number plus 1. So if the desired X ever gets bigger than 240 plus the width of that car in half the width of that car, that's when we're going to delete this clone. It's going to be similar for this guy, only in this case we're going to say it's going to the left, so it's going to be minus, and it's going to start at negative 240. And we're going to use this exact same thing here. So if I can get on that, nope, I want the green one, green, duplicate that. Then delete this clone. And did we call check if off screen left the position? We did. I think that should get rid of the car. Should we give it a shot?
Mm-hmm.
Alright, let's give it a shot. Make the screen bigger again, and let's play. Now we have to wait till those cars get all the way over. Is it going to do it? Is it going to go away? A new car came on. Goes across the screen, and it didn't go. Yep, it did go away.
There was a delay there.
There's a delay. You know why that delay's there? Because Scratch isn't letting the car go all the way off the screen. Right? And so if Scratch did let that car go all the way off the screen, we wouldn't have that delay. And I'm going to just leave that for now. There's probably ways that we could fix that up by changing the widths of the cars and everything. But I'm going to leave that for now. Okay? So we've got a nice little interesting puzzle for us to get through, right? We need to get through these cars, and it's actually not that hard because right in the beginning. But look at this. We have a problem. I can go right over these cars. And that's not very fun. That doesn't make the game a challenge. We need to make sure that the frog knows when he gets hit by a car. And Scratch has some nice stuff built in just for that type of thing. So one more thing I want to keep track of, and we're going to have to keep track of this as a variable for everybody, is whether the frog has been hit by a car. Is hit by car. And that's for everybody. And so in the stage, I'm going to make sure that we say that he hasn't been hit by the car in the beginning. False. He's not been hit by a car. But cars, when they check their position, it would be very easy for them to do one more little thing. Check if hitting frog. So we're gonna, after we checked, see if we're off the screen, we'll check to see if we're hitting the frog. And Scratch has just a simple little way of doing that. It might be, I don't know if it's very performant, if it takes a long time to do or not, but it's right inside sensing. And it will say if is touching. There's an is touching. Touching, if we are touching the frog, well, if we're touching the frog, then we should definitely set is hit by car to true. And that's it. That's all we're going to do there. It's going to be up to the frog to figure out what to do if he's been hit by a car. So that's a very simple thing. We'll just leave that right over there. The frog now, there's a bunch of things that should happen if he's hit by a car. He should deduct its lives, he should start the time over, he should reposition himself to the bottom of the bin. But one of the things that they said, if you remember from our little competition, it said that, well, this needs to go backward and forward. There's something about saying ouch.
An ouch, ouch animation.
Where does
I don't know where it is, but
jump? Oh yeah. If frog is hit by a car, an ouch animation takes place. So we can do that. That's easy enough to do. Let's get back to our Scratch game. So one of the things when we handle a frog tick is we're going to do another thing, which is to check if hit by car. It sounds a lot like what we did in the other one, right? Well, we're going to do that here too. And for now, we'll stick that right there. And all we're going to do is say if, and put an equals in, and the data is if we were hit by a car. If that's true, it doesn't matter how many cars we've been hit by, then we are going to say ouch. And say is right here. Actually, let's go ahead and let's do it for 1 second. So let's see if that works for us. Let's do this again, big, like that. Let's click play. Is that car gonna hit it? Look at that! We've got our ouch animation now. So it does that for 2 seconds. And we never set it to not being true. And because our ticks are based on the timer now, we have these very funny thing in here. But we've done the requirement. It says ouch. There's a whole bunch of other things we're going to have to do to make that all work, right? We'll have to make that ouch kind of go by a little more quickly, reset everything, and get it put back again. But we'll save that to the next one. But we've made some pretty good progress here.
yay!
At the beginning, we only had 1 car in each lane. Now we have multiple cars in each lane.
Yay!
In the beginning, the frogs didn't know if he was hit by a car. Now he knows he's hit by a car.
Yay!
Why are you cheering for the frog dying?
Sorry, frog.
Anyway, it's a game now.
Yeah,
And
it's not a real frog.
And it's not a real frog. And he doesn't really get hit by a car. He's just some pixels on a screen. So it's okay. The frog will live to frog and jump across in another day. We'll get to where we can reset the game in our next one. I think this was pretty fun. I think it's becoming more and more of a game every time. I hope you're following along and have a game that you can make fun too. All right. Thank you very much for being a part of this with us today. We'll see you next time. Bye-bye.
Yay!
Bye-bye.